Hello guys, in this video I would like to explain Taylor diagram, which is a useful tool for evaluating machine learning and deep learning models and maybe other models which you can use to simulate data and maybe other experiment you would like to evaluate their performance. Before this video I have done two videos. One was about the Taylor diagram, the theoretical background, and the structure and the interpretation of the Taylor diagram. This is first video. And the second video was about how to create a Taylor diagram using R and RStudio, and the package used, the library used in that case was Openair. So if you would like to know about those two videos, the links to those videos are given in the description of this video. Just go and click and you will see the details about Taylor diagram and the detail about how to create a Taylor diagram in Openair or library. In this video, we'll explain about to create a Taylor diagram using Plotrix library, that is also our library you can see here. So if you have not installed, you need to install Plotrix and then call it, load it by using library and Plotrix. Then you can see. And in this video, I've choose the data that is again for different machine learning and deep learning models, the output. But you can say that deliberately I choose the data, intentionally I choose the data which has the correlation, some negative correlation, because I want to explain that you can make then the plot like, for this whole range from -1 to 1. If the values are greater than 0, like somewhere here greater than this 0, then you can plot this part, only the half part. But if you have some data which have negative correlation, then you need to plot like this. That is some negative correlation, just, which are very close to 0. Then you need to plot the whole range. And this is optional. You can choose, you can plot half of this from 0 to 1, or you can plot from -1 to 1. This is optional and depend on your data. So let's see how we can do this in R. Okay, this is now, you can see you need to install the package Plotrix, Plotrix, by using this command install.packages if it is not installed already. And then you need to load Plotrix, and then you need to set path to your data. So my data, my path to data is this one. I can use this, and it's up to you. You can choose. And then you need to read the file, and that's my file is like this, the name.csv file. You need to read and store the data in TD. So the data is now stored in TD, and you can see the format of the data as I told you in the previous video when I was creating Taylor diagram in Openair package. You need to know about the data format. That is the most important thing. Like you can see now the data is different in different format. I will show you the data. Okay, like the data is here, my data is here. I will show you the data in CSV file, and you can see this data is quite different. You can see this is the year and this is observed data, and then each model ANN, SVM, JVM, RF, GRU, RSTM, and RN. And you can see this format is quite different. It is not like the format which I have shown to you in Openair package. So this means that this is very important. You should know the format according to that function which you are using. Like the function we have used from Openair package, that was having different format of the data, like observed data and then the model data. And then the model data below ANN there was SVM, and again you need to copy and paste observed data in front of that in this row, in the observed row. So observed data is repeated for each model, and you need to write each model here. Below the ANN there was SVM, JVM, and at the end RNN. And then you need to write something like model. You need to write like to identify that which model it is, like this is ANN. Then you need to write mod, MOD, and then you need to write that is anim, and then for SVM you need to write SVM in this column, like I will show you again because I have the code is open. So this is for that Openair package. So you can see now, you will see the data, and that's quite different. Look at this. You need to write observed data and then model data, and then you need to add in the ANN data and then SVM data and so on. You need to write this as well because you need to identify this by using this model, that which data belong to which model. So that means the format is quite different. For this Plotrix, you need to have the data like this. So it's very simple and common. For Openair, that was different. But this depends which package you like to use. You need to know about the data format. Okay, now you know that the second column of this data, as this represent the column, this means second column of this data. This is observed data, and you can see again. Just look at this. Again, because that was read from the first one, you need to again read this file because that show me the data from Openair package. So again, now you will see. Yes. So first column is here, and the second column is observed data, and then the remaining columns are model data. So we need to subtitle this. That not similar to, yes, similar to model output. So you can see. In fact, we have observed data as well. So observed data is now OBS, second column. Third column is ANN, fourth column is SVM, and so on. So now you have data in the name of the model. This will not work with this, so I don't need to write this. Just delete this. And now you need to define colors. Define colors and symbol for each model. Colors is blue, red, green, purple, orange, brown. Fine. 1, 2, 3, 4, 5, 6, 7. 7 models, 7 data, because observed data is just a reference data. You do need to have color for it. Symbol is now here. So colors are stored in the colors, and symbols are in C. This is 19, 17, 15, 18, 8, 3, 4. This is because you represent. You can see this how to represent the color with the numerical values. So these are different colors. Now you need to plot the first two data set. I mean, you need to plot ANN and with observed data. Start the first model to create the base Taylor diagram. This will create the base Taylor diagram. So we need just to plot the ANN, the first model data with the observed data. This will give you the base Taylor diagram, and then you can add these models. So let's create this. So this is now the base model. The observed data is here, which is reference data, and this is now, you can see in blue color, that is ANN is here. And you can increase the font of the text by using this. Just try this and just look at the plot. Yeah, you can see now it's too much bigger. So I would like to use the one. Okay, so you created the base plot, the base Taylor diagram. You need now to add the rest of the models to the plot, to this plot. Taylor diagram, again the same function, observed with SVM, add true. If you remove add true, or if you write add is equal to false, then this will create another base diagram, and this will ignore this one. You will never see. This will be overwrite by this one. And similarly, if you write false for each, then you will have the last Taylor diagram, this one, and not all these. So add true mean this will be added to the baseline, the base Taylor diagram, and you will see colors. You can choose. So this one, okay, color is the first color, that is blue for the ANN, and TCH symbols, that is symbols 1. So symbol 19 has been chosen for ANN. And now for this one, color is true, so you can choose color 2. 17 for this one. Red color is chosen for, oh, I'm sorry, I explained mistakenly wrong. These are the colors, and these are different symbols. So symbols mean you can see how to represent different symbols with the numerical. And okay, so the colors are here, and these are symbols. So just a correction for the mistake which I have done, a few moment earlier. So now this is colors, that is 2, that is red for SVM, and the symbol is 2. 2 mean in this one, that is 17 for SVM. Just do this, you will see, and you will have another line, another symbols added to the plot. That is this one. This is triangle, and this is the red color. This is added to the baseline model, which is this one, the baseline tether diagram, the base tether diagram. Similarly, you can do the same for JBM. True, that will be added. Color is free, that is green, and you see its symbol is 3, so that is 15. So whatever the symbol from this, you can see this for detail. And just look at this, that the font third will be added in the green color. Just look at this. Yeah, that is JVM is very close to observed data. So this one. Similarly, you can do the remaining the same interpretation for these. You will see the same. So now you have plotted all these. You can see some of them are here. 3 are here and 4 are here. This one, this one, this one, and this one. Now you can plot legend. So legend is equal to top right. You can change this to center. You can change this to top left. And legend is past. See, these are the models. These will be the models. Color is colors. This will give the same color which you have defined, like this. Because this is already defined. So colors mean the same colors for these models. Like for ANN, that is blue. For SVM, that is red. And for RNN, that is this one. And for LSTM is brown. Similarly, with the same symbols, because there should be no confusion, no contradiction in the symbols in the color. Just do this and you will see a nice legend to the Taylor diagram. Yes, so this is now the complete diagram. A Taylor diagram, you can see observed data, and then these are the model data, and you have the interpretation in the first video. The link is given in the description of this video. So you can now interpret your result. What is meant by these models, the performance of these models, which model you can choose. And this is the key, that is, the legend which can give ANN, SVM, and JVM, and RNN is here. Okay, and this one is LSTM is have negative correlation. It's slightly negative correlation. Remember that if you have this data, I intentionally choose this data that some data has negative correlation. So then you need to plot the whole, the plot for the whole range of the correlation, that is from -1 to 1. This is from 0. This is from 0 to 1. Then you need to plot Taylor diagram for the whole range of the correlation coefficient, that is from -1 to 1. What you need to do, you can change in the base plot. This is the best Taylor diagram. You can choose this. This is true. This means this will give you the hop plot for the hop range from 0 to 1. If you write this, if you change this to false, you will see now the results, how it look like. Again, this is the best plot. I will see. Yeah, okay. This is now with the whole range. You can see friends from -1 to 1. So you will see now this is ANN, that is the red blue color, and you need to add all these plots and you will see. Let's look at this. Yeah, this is now the plot, the whole entire entire range. Because there was some correlation slightly less than 0, so we can see JDM and ANN, SVM, and the other models. And now you can add in the same way as I did the region, and you will see the complete plot. That's the complete plot. Yes. Okay, now again you can run again, because this is stretched, so you will see now you will have a nice plot now. Okay, now because when you plot for a small area and then you stretch, that's not looking good. So this is now for a whole plot. You can see more observed data and then the models data until here. 1, 2, 3, 4, 5, 6, 7 models, and you can interpret the results now, whether to choose which of these models depending on the performance. So this is all about what we would like to learn today. To create a Taylor diagram and Plotrix, that's another library or we're using in R, and it's depend up to which library you would like to use. which data format is easy for you. The link to the code I have used in this video is given in the description of this video, so you can go just click and you will be directed to GitHub, and you can see this R code you can copy and you can use. You can change the path to the data, and according to your data you can create tether diagram. Also, the link to the data is also given. If you like to see the format, how to format your data, you can help from the format of the data. So I think this is enough for today, and thank you very much. See you in the next video. Ciao.